Okay, so a few more things just about R. I've already showed you some of the commands to do mathematical operations, but what I wanted to do was just to talk a little bit more about how R is operating right here. This command, this less than sign here, is the same as the prompt in the bash shell. Basically, R operates on the same kind of loop that R operates, where it reads what you type here, evaluates it, and then prints out the results. And so when you do the command 4 times 5, R is now reading that result when you press enter, evaluating it, and then printing out the result. So it's operating in exactly the same way as the command line interface that we've learned about on the bash shell. Now, one thing that can happen while you're working in this sort of command line interface that's a little different from the shell, but we ran into it a bit when we did loops in the shell, is that you can sometimes find yourself in a situation where you've done a command incomplete. So if I just type 4 plus, that's not a complete R expression. So when I hit enter, what it's going to do is R is going to change the prompt from this less than sign to a plus sign to indicate that it's waiting for the rest of the expression. So if I get stuck at this point on a PC, I can push escape and it'll back out of that. If you find yourself with that plus there at the prompt, just push escape on a PC or Control C on any other computer, and it will back you out of that stuck situation. A common way that happens is if you have an incomplete set of parentheses, and sometimes it's easy to lose track of where you made the mistake. It's hard to fix. R follows the same sort of order of operations that you learned back in school. So if you want to do things like 3 plus 5, let me do that properly, 3 plus 5 times 2, right? This is going to give us 13 because first it will multiply 5 by 2 and then it will add 3 to that result. But if I wanted to do the addition first, what I would have to do is put in some parentheses. That gives us a different result. So by putting parentheses around parts of an expression, you can force the order of operations to be different. Sometimes using parentheses is also helpful for making what you're doing clearer in terms of more complex expressions. So yeah, lots of things that are that's sort of pretty standard. R will also sometimes display scientific notation. So if you have a very large or a very small number, so here's a very small number, and it's displayed it now as 2 times this e here is e times 10 to the power minus 4. So that scientific notation can crop up when you have particularly large or small numbers. And you can do the same thing. You can write a number that way too. So if I do 5e to the 3, that's the same as 5 times 10 to the power 3, or 5,000. In this case, R is writing it out for me, but if I use 5 times 10 to the 30, it'll just keep it as a scientific notation. I talked a little bit about functions already, or I introduced you to a few functions. There's many sort of built-in mathematical functions. So we have things like the sine function. things like the log of 2.718. It's pretty close to 1, so that's the base of the natural logarithms. If you want log base 10, you have to use 10. And so the way that you can tell that we're using a function is that there's some name, and then it's followed by parentheses. And that gives us, that's how we know it's a function. So the things that go inside the parentheses are known as arguments or parameters. And there can be, in this case, there's just one of them, but there can be more than one argument as well. One of the nice things about RStudio is that it does what's called lookup automatically. So right at the moment, I typed log, and then RStudio is very helpfully telling me all the different log functions in the thing that start with log. So that can be very helpful. And then it also, once I've chosen one, and I chose that by choosing tab, it then tells me what I have to put in the what kind of arguments that I need. In this case, there's just one argument called x, so I can get at that way. The other nice thing that RStudio does is when you put in a parentheses, it actually puts in the matching parenthesis as well, and that's a great way to avoid making mistakes. The other thing you'll notice is that if I go up here, and it works in this text editor too, if I put my cursor next to a parentheses, RStudio will highlight the matching parentheses. And this business of making sure that your parentheses match is one of the things that is the most painful about writing computer code, because you can end up with nested layers of parentheses, and then if you miss one somewhere or misplace it, it can really make your life miserable trying to figure out where the error is. And RStudio does a really nice job of fixing that, or of reducing those errors, both by adding the parentheses automatically for you, and then also by doing what is called brace matching. As you go through the code, it identifies where the matching parentheses or brace happens to be. So those are all good things. Now, a few more operators that are kind of useful. There's a number of operators that will return logical results. We'll talk more about variable types in a bit. Logical results are true or false. So in this case, we might want to know, is log base 10 bigger than 0? The answer to that, of course, is false. It's less than 0. And we can also ask, is log base 0.05 of 1 bigger than 0? Now, this is strictly false, I think, so let's just see what we get. Yeah, and so that should be, in fact, exactly equal to 0, and that's true. So the equals sign by itself is actually the same as the assignment operator. So in R and in many other programming languages, you actually have to use two equal signs if you want to do the logical comparison. Is this thing equal to that thing? The other wrinkle that you can run into when comparing numbers is that it can be risky because you can get a situation in which very, very tiny differences between two numbers will mean that they're not equal. But in fact, for all intents and purposes, they're identical. So it works well with integer values. It doesn't work at all when you have, or not at all, but it doesn't work very well when you have floating point values like 0.4342495. It's not going to do a very good job. There is a function that can do that called all.equal, which will do a comparison of floating point values with a little more robust comparison. Okay, I talked about the assignment operator already. Last thing to talk about is to briefly introduce a couple more things here. I did this previously without really saying very much about it, but objects in R are not always just single numbers. So we've got a whole bunch of things here where we can assign things like A is the log of 1 equal to 0. I should keep spaces around my operators to make everything clear. Okay, so I've assigned the result of this operation to this variable here, A. It's just got a single result. But they don't have to be just single results. They can also be vectors. And so I showed you this one before. X is 100 normally distributed random numbers, and this is what is called a vector. So this is a vector of random numbers, has a length of 100. Length of 100, is 1, right? Because it's a single number. Oops, what I meant to do was length of x, which is 100, yeah. And pretty much everything in R at some level is a vector or some other kind of object that's similar to that. So this is actually quite important because, so this notation here, the colon is the operator that says, give me the vector that goes from 1 up to 10. And you can actually do calculations with these vectors. So for example, if I do 1 up to 10 times 5, I'll get all of the values of 5. So 10 times 5 is 50, 9 times 5 is 45, and so on. We'll talk more, there's a whole section that we'll do just on understanding this vectorization process and how you can take advantage of it to do calculations very efficiently. Last thing I wanted to, or two more things actually I wanted to talk about. Some of the same functions that we used in the shell for understanding what's going on are still present here. So the ls function in the shell gives us the list of objects, and it's a function here, so I have to put the parentheses in. And so now it's listing A, my first model, which was the statistical model I fitted X and Y. So it's showing me what the objects are that are present in the workspace that I can do calculations with. If I try and summon an object that isn't there, let's call it ham, then I get an error message saying object ham not found. What this often means is that I've misspelled it, or I didn't, when I saved the object, I changed the case. So for example, if I do capital X, that's not found, even though small x is. So R is case sensitive, and it does do those things, treat those things differently. And you might be wondering, in the bash shell, if I just type ls, it works, right? I don't have to put parentheses after it or anything. If I do that in R with an object that's a function, like ls, what I'm going to get is a whole bunch of R code, lots and lots of R code. This is actually the source code for the function ls. So just by typing the name of it, it prints out the code that it is actually going to use. And it's not that simple. It does quite a lot of work, but it can be a handy little trick to figure out what's going on with functions. Another function that works is the rm function for remove. We have to give it the name of the object that we want to remove, so I can remove the object A. Now it's gone. If I wanted to remove everything, much like doing giving the wildcards in the shell, I can do that here too by providing an argument to the rm function. And it has a range of arguments, in this case, list. And what I'm going to do is I will provide the list by using ls. So this is an example of what is called nesting functions, one inside the other. So I'm going to use the ls function, which returns a list, a vector of the names of the objects. And then the list argument wants to have exactly a structure like that. So if I do that, then ls, and we'll find that my workspace is now empty. Now you may have noticed that, okay, when I was doing assignment here, so A is true, right? I was using this 2-character operator to create my objects. That's sort of the R standard, but the equal sign works as well as an operator, assignment operator. And although the convention is to use this one when you're doing your coding, there's one place where you always have to use the equal sign, and that is when you're assigning arguments to their names. So R allows each of the arguments to the function has a name, and it can either match up those by, why is it not giving me the list of arguments? There we go. What I've done here is ask for the list of arguments for RM. It can either match them up by name. So you see, here's the list argument. Then there's a position argument, which tells it where to actually do the removing. Environment is another way of specifying where to do the removing. And so by giving it a name, I can basically directly assign the results of ls to this name, and then the function will use it. The other thing that happens with the other way you can do it is by position. So in this case, if I was to not name the arguments, it would basically match any sequence of arguments and try to treat them as objects to remove. If I do the same thing for formals for the function log, oh, that's an internal function, so it doesn't actually have any internals or any formal arguments, but here we go. So log x and base. So the first argument, if I don't name it, will be assumed to be x. And if I do name it, then I can put them in different order. So if I give it 2 arguments now, so I say, let's see, log of 2.78, and I'm going to do that to 10. So now I've given it 2 arguments. The first one will be treated as the number to be logged. The second one will be treated as the base. And so that gives me a different number. Or I can do the log of, no, that's what I want. And that will give me the base of the natural logarithms. So that's a little bit about functions. We're going to see lots more of these functions and things like that. So if that all seems a little bit like Greek, don't worry about it. Oh, I guess the second thing I was going to say is I can also name these objects or name these arguments. Right, so I can say that one's x and this one is the base. That gives me the same result. But if I name them, I can actually give them in any order. So, for example, I can do this. And I'll still get the same result. If I was to try, well, in this case, that's kind of a poor example, isn't it? Because that would give me the same result no matter which order I put them in. Let's try that a different way. Let me change x to 10. Okay, so if I do that now without naming the arguments, and I do exp1 and 10, I'm going to get, in fact, the 2.7 whatever, right? That constant rate to the base 10, because it's assuming this is the number I want, and that is the base. So naming the arguments allows us to be a little sloppy about what order we put them in. And for simple functions, it's usually better to actually stick with the order, even if you're going to name them. But sometimes some of these functions have really long, many arguments, and then you need to name them because you may not want to use some of the arguments in particular. You just want to change one that's way down in the list of arguments. So then you need to name them. But if you're just using one argument or something like that, usually it's okay not to name it. Whatever the first argument is usually going to do the right thing, even if you don't provide a name. Okay. The last thing to talk about before we move on is packages. One of the things that R has going for it is that it has a great number of what are called packages. Packages are ways that you can extend R. So someone can create a bunch of R code that does a particular task and put it together in a package and then make it available for anyone who wants to use it. We can see how many packages I have installed by doing installed.packages. All of these are sort of extra packages that I have added on. Well, some of them are actually what are called the base packages. Well, I wouldn't even want to guess actually which ones are base packages and which ones are core. But you can see I've installed a lot of packages because I try doing lots and lots of different things in R. If you typically you need to know what the name of a package is, and I'll show you at another time how you can do that. And then once you know the package you want to add, you can say install packages again, right? So before I did installed packages, this is install packages. And there's one, I think, called tween R that I just read about today. And what R is doing now is connecting to the what's called the only available in source form. So I don't want this package. Okay, yeah, so what happened there was it found the package on the Comprehensive R Archive Network, or CRAN, and was going to download it, but this is actually a package that is not available. It's not been compiled, so you actually need to have a variety of extra compilers. In general, unless you're doing pretty advanced stuff, this is a sign that you are not going to be using that package. It also had a dependency. So this function or this package depends on another package that I don't have installed on this computer, rcpp, and then it automatically downloaded that package for me and installed it. So lots and lots of different things that you can use to extend your use of R. If you want, now that I've installed that package, I can make it available to use by doing library rcpp. There we go. And it's giving me a warning message that it was built under a more recent version of R, So I need to upgrade my R on this computer too. That's also a worthwhile point to make. Warnings are usually just there to let you know that things are not quite as they seem. R was able to do what you asked, but for whatever reason, it wasn't perfectly successful. Okay, but it was able to finish it, whatever it was. It's usually a warning is usually assigned to take a second look at whatever the result was and really make sure that it's what you expect it to be. The other kind of message that you'll get, and I generated one of those earlier by looking for an object that I didn't have, so ham and eggs, right? So this is an error, object ham eggs not found. So an error means nothing. R didn't do anything. R tried to do what you asked, in this case, look for the object ham and eggs and print it out, but didn't exist, so it returns an error. All right. Well, that was a bit longer than I expected, but there you go. That's a more detailed look into about the R software. And now you're getting ready to start to do a little bit more work with the R language itself in the next video.